So this is question 18, higher 2012, paper 1. We're given a graph of a function y equals f of x. Two statements. One concerns f of x and one concerns f dashed of x. And we're asked whether this one's true or false, whether this one's true or false. Once we know that, we can choose the appropriate answer. Now, there's two things on the go here. One is, what's the meaning of f of x? And the other is, what's the meaning of f dashed of x? So a little bit of background and exploration about these things first, before we tackle the question. So we'll get our background up to date first. Here's a particular example. This is the graph of the function f of x equals x squared minus 1. If we look at this particular point, the x coordinate is 0.5. If I put 0.5 into this function, do the calculation, 0.5 squared is 0.25, take away 1, you get minus 0.75. And then look again at this point. The coordinates of this point, 0.5, negative 0.75. So the reason that we can answer questions like this is because the values of f of x are given by the y coordinates of these points on the curve. And for all these x values being negative 1 and 1, the corresponding points on the curve have negative y values. So we would say that this particular function, f of x is less than 0 for any value of x lying between negative 1 and 1. Similarly, for points up here on the curve, we'd know that f of x is greater than 0. So the heights of points on the curve, positive here, that occurs when x is greater than 1. Or, there's another branch here, for x being less than negative 1. So you choose any value of x, value of the function is positive. Choose a value less than negative 1 for x. So really this is the dividing line between positive and negative values of the function. So in here, values of the function are less than 0. Heights of the points in the graph are negative. And in here, values of the function are greater than 0. Heights of the y-coordinates of points on the graph are positive. And similarly, over here, values of the function greater than 0. The graph is above the x-axis. So that's three areas. Positive values for f of x, negative values for f of x, positive values for f of x. So let's now look for this particular function. Let's look at the meaning of f dashed of x. That's indicating that we should differentiate. If we differentiate x squared, we get 2x. Differentiate minus 1, it disappears, you get a 0. So f dashed of x equals 2x. And for this particular point, where x was negative, x was 0.5, in this case, different formula, twice 0.5 is 1. So we look at this point and say, what is it about this point that gives us a value of 1? You'll recall that differentiating tells us the slope of the curve at a particular point. So let me just draw a tangent to the curve at that point, and you can see that that tangent has slope of 1, gradient of 1. If we ask then questions about f dashed of x being greater than 0, we're asking when is the tangent to this curve. When does it have a positive gradient? Now you just watch that line move, the tangent, what we call a wandering tangent. Positive gradient's uphill. At that point, it's got a gradient of 0. It's neither uphill nor downhill. But for these points, the gradient of the tangent is negative, going downhill. So asking questions, for instance, like when is f dashed of x greater than 0, we'll get an answer whenever x is greater than 0. All these points to the right of the origin, and so this is the dividing line for f dashed of x. To the right here we have the gradient of the curve being greater than 0, and to the left we have the gradient of the curve being less than 0. Tangents have a downhill slope. So f dashed of x less than 0, that happens when x is less than 0. So for any value of x less than 0, the curve has a downward slope. So that explains the meaning of f dashed of x. So let's look at the graph that we were given in the question. So here's the graph from the question, and we're going to look at f of x. And the statement that they make is f of x is less than 0 for x anywhere between s and t. There's s and there's t, particular values of x on the x-axis. So let's look at all the values of x in between s and t. The corresponding y value of the point on the graph is negative. You can see the point there, it's below the x-axis. The curve lies below the x-axis for any value of x between s and t. So that statement's true. Any value of x less than s, the function value f of x has gone positive. It's above the x-axis. And for any value of x greater than t, again f of x is greater than 0. So f of x is less than 0 only for values of x between s and t. So this statement is true. So let's now look at f dashed of x. And the statement in the question says f dashed of x is less than 0 for x being less than q. And q is the x coordinate of this point here. So basically there's q on the x-axis. And remember that f dashed of x is actually measuring the gradient of the curve. Downhill, negative. Uphill, positive. So for values of x greater than q, as you can see, the gradient of the curve is positive. F dashed of x is positive for any value of x greater than q. That's not true to the left of q. For x being less than q, the graph is downhill. The gradient f dashed of x is negative. However, that's not true for every single value of x less than q. Did you notice that at this point the gradient of the curve, the gradient of that tangent is 0? Now that means that f dashed of x is not less than 0. There is one value of x, namely 0, where the gradient at this point is 0, and it tells you that that's a stationary point. That's stated in the question. So at all stationary points, the gradient of the curve would be 0. You can see the tangent at that point is horizontal. It's parallel at this point to the x-axis. So this statement is not true. It takes one value of x, namely x equals 0, for this statement not to be true. So in general, for all values of x less than q, f dashed of x is not less than 0. There's one in particular where it's actually to 0. So this is not true, this statement. So here's the actual question. So remember, graph below x-axis between s and t. Yes. So this is true. Graph going downhill anywhere left of q. Not true. Flat there. Isn't going downhill. So that was false. So what choice did we make? Only statement 1 is correct. Choice B.